Hello students, welcome to Legacy IAS Academy. In today's video, we are going to discuss about a recent event that has happened related to NASA's very important mission that is called as Psyche mission, where it has fired a laser beam on the Earth. Now, this is considered to be one of the major breakthroughs in the area of space travel as well as in the area of deep space communication. So, let us try to understand why this NASA's mission has fired this laser, what is the purpose behind this, and how it has done it, and what will be its impact on the future space mission. So first of all, to give you the brief context of this particular topic, NASA's Psyche aircraft, which is going toward a asteroid which is also known by the name of Psyche, situated somewhere in the major asteroid belts of the solar system, obviously, which is located between Mars and Jupiter. So currently it is around 16 million kilometers away from the planet Earth and has successfully fired a laser signal at the Earth. The spacecraft, as we have discussed, is on its way to the asteroid. Now this Psyche asteroid is also not any other kind of asteroid, but it is very unique in nature. Why it is unique in nature? Because most of the asteroids are largely made up of rocks, different types of rock systems, while this asteroid is largely made up of metals and not any other metals, but this what we can call as a nickel metal. And nickel is something that is believed to be the initial metal, or is believed to be the metal that formed when the solar system was basically evolving, and thus it is believed that this asteroid is the nickel iron core of asteroid is believed to be a part of the early planet and its core, and studying of this could provide unique insights into the impenetrable iron core of our own planet. Now we know that when we try to understand about the internal structure of the Earth, we face a lot of challenges, a lot of limitations are there, obviously, because as we go inside, deeper inside the core, deeper inside the Earth's surface, temperature increases and we cannot understand clearly the structure and the kind of materials that are present there. Thus, since we cannot go into the core of the Earth, if we are able to find out the core or the core of similar planets like Earth before, we can have a much better understanding about the Earth's internal dynamics. Thus, simultaneously, it will also carry out another mission that might hold the key to the future space exploration. Now, what is a Psyche? So, first of all, as we can see from this particular image, here it is our solar system. This is the Earth. Here we have Mars. So we have Mercury, Venus, Earth and Mars. These are the 4 planets which are referred as inner planets. And between the inner planets and the outer planets that is consisting of Jupiter, Uranus, Saturn, Neptune, we have an asteroid belt, and within this asteroid belt we have an asteroid that is referred as 16 Psyche. So the main objective of this Psyche mission is 3. First, it will try to understand a previously unexplored building block of planet formation, that is iron cores, as we have discussed, because Psyche is made up of exposed nickel iron core. Second, it will look inside terrestrial planets, including Earth, by directly examining the interior of a differentiated body which otherwise could not be seen. And third, it will explore a new type of world. For the first time, examine a world made up of rock, not made up of rock and ice, but made up of entirely metal. Thus, now this is the primary objective. Secondary objective is also where it will be helpful in understanding and experimenting on the deep space communication. And in this regard, if we talk about first of all that what is the space communication and how generally it is done. So like all kind of communication that we have on the Earth, for example, wireless communication that we do, spacecrafts encode data on various bands of electromagnetic frequencies and then send it toward the Earth, where we have a receiver. This receiver receives the data, transforms it into the meaningful information such as HD images or sound waves or something like that. Currently, if we talk about space communication, most of them are based on using the radio waves. Now, there is a reason behind that. The reason is because the radio waves currently are the only spectrum, or what we can say the electromagnetic spectrum, where it has a desirable properties which can help in propagation of the data from space to the Earth. The reason is because if you try to understand, the radio waves are having a very low frequency and thus they have a very larger or high wavelength. Now, due to this large wavelength, radio waves poses a unique properties or ability to pass through the atmosphere regardless of whether it can pass through the foliages, and most importantly, it can pass through most of the building materials as well as bend around obstruction. And that is why when it is sent through the space, we can receive accurate data, the transceivers, or we can say receivers at the ground, can receive more accurate data and full data. Third is the longer wavelengths. Basically, that is the characteristic of the radio waves. They tend to not scatter when in contact with any other kind of interference. That data that is sent via space to the earth will not be garbled because of the obstruction. So this is the reason why most of communication, space communication, is based on the radio waves. Let us try to understand this in more detail. So if you look at this particular image, you can see the various different types of electromagnetic spectrum, from the larger wavelength to the smaller wavelength, and vice versa, from smaller frequency, shorter frequency, to the larger frequency. So first of all, we have the radio waves, which is having a very large wavelength but short frequency, and this is used in communication such as aircraft communication, amateur radio, or even AM radio. Apart from that, the second spectrum we have is microwave, which is generally used in the microwave oven for heating of the objects. Then third we have is infrared, which is generally used in the TV remote control or night vision goggles used by the soldiers during the time of wars or carrying out operations. We have then visible spectrum, which we know that a spectrum through which we are able to see the world around us, that is something that our eye can interpret. Then we have ultraviolet range. Ultraviolet is something that is obviously ultraviolet B, if we talk about, or ultraviolet C rays. They are threatening to us, dangerous to us, and fortunately most of these are trapped and absorbed in the stratospheric layer of the earth itself due to the presence of the ozone gaseous molecules there. Then we have the X-rays, which is used, for example, if you are passing through the airport security, then your baggage, basically whatever is present inside your baggage, that is taken by X-rays. Apart from that, it is used for diagnosing broken bones and all such elements like that. And PET scan is something, or terrestrial gamma ray flash is something that is associated with the gamma ray. So this is the general electromagnetic spectrum of different wavelength that generally is emitted from the sun. So from these, radio waves, as you can see, are most important ones, are majorly used for all kind of communication, including space communication. Now here is the issue. The problem is that generally scientists have seen that if they are able to use higher bandwidth, that means rather restricting the frequency, if they are using a wide range of frequency for data communication, the information or data can be carried out at a faster speed, and also more data can be packed, if we talk about, per second. The scientists would ideally like to transmit data at the highest bandwidth possible to increase the rates of data transfer. And the problem is, this throws up its own set of challenges, because we know that if they are using a higher frequency data, the wavelength will become shorter, and if the wavelength becomes shorter, they tend to scatter when they come in contact with any interference. And especially if the data transfer is being done from the outer space toward the earth, there are a lot of obstruction in the path, including atmosphere, and thus the data that we will receive will not be, what we can say, accurate in nature. And it is in this context the deep space optical communications, that is one of the objectives of the Psyche mission, will come into play. And this is for the first time that NASA is trying to pioneer the use of near infrared laser signals for the communication with a spacecraft, rather than restricting to the radio wave spectrum. And DSOC will thus allow data rates at least 10 times higher than state-of-the-art radio telecommunication systems of comparable size and power. And that is why DSOC is very important. Especially, it can be a major breakthrough in the field of communication if we are able to succeed. And enabling higher resolution, obviously, if you are able to transfer at least 10 times higher data, that means what will happen? The data that is being sent by the space missions, that is the data that is sent by what we can say satellites, will be of higher resolution. The images that will get will be obviously of better quality, that means higher resolution. Larger volumes of scientific data can be collected in a short span of time, and even HD videos could be streamed from the space directly on the earth. And thus the Psyche aircraft has become the first spacecraft, basically we can say, to carry out a DSOC transceiver, and it will be testing high bandwidth optical communication to earth during the first 2 years of the spacecraft journey to the main asteroid belt, where it will go and explore the site. So how this technology will basically work? Let us try to understand what is the basis of this particular technology. So as we can see that the spacecraft that is in the space will send a signal to the earth. So the spacecraft will have a transmitter, and on the earth we'll have optical receiver. So basically the basis of transmission is based on extremely precise pointing, because you know that in the space everything is moving. The spacecraft is traveling at a speed of thousands of kilometers per hour. The earth is moving around the sun. The solar system itself is moving around the Milky Way galaxy, the center of Milky Way galaxy. So due to this region, what will happen? If the data is being transmitted by the spacecraft and if receiver is not pointed in right direction exactly, then it will not be able to gather or collect the data. Thus, the flight laser transceiver and ground-based laser transmitter will need to point toward itself with a very great precision, a high degree of precision. Not only that, since the transceiver is transmitting the data from the spacecraft toward the earth, there is a need to isolate this transceiver from the craft's vibration as well. And third is, since the earth is continuously moving around the sun, there is a need for compensating the DSOC ground and flight system as well, because of the changing position of earth and the spacecraft. And last, the long distance between the spacecraft and earth will cause a lot of obstruction in transmission of data. That is something that also has to be taken care of. Now, how DSOC can help us, or how it is going to play an important role in the future, especially in the dimensions of space travel. So it is believed that it is taking optical communication. Earlier also NASA has tried to have some sort of optical communication, not only in radio wavelength but infrared wavelength as well. However, this was the first time DSOC has taken it into deep space, paving the way for high bandwidth communication that is far beyond the moon and over 1,000 times farther than any optical communication test to date. That means if it becomes successful, the communication between Earth and the farthest region of universe or solar system where it is possible will become much more greater. And thus, with humanity's ambition, we know that it is to travel in the space in future far beyond the moon, obviously, because in the long term, moon is something that is considered as a pit stop. When you are moving from Earth to Mars, let us say, so you are going from Earth to moon, then moon will be acting as a base, and then from the moon, then the space travel or the space travel will be taken to the Mars. So in that regard, improving communication between the deeper space and the earth becomes very crucial, very critical, and that is where DSOC is going to play a very important role. It is paving the way, we can say. In other words, if you want to describe it, we can say that DSOC is paving the way toward higher data rate communications capable of sending scientific information, high definition imagery and streaming video itself, and thus it will support the humanity's next giant leap, that is obviously sending humans to the Mars. So in this regard, it is a very pioneer experiment that NASA is conducting via its Psyche Space. That is all about this particular video. I hope you understood the basics behind it. Thank you very much.